All right, this is lesson 6.3. That's why I erase these little notes that were on here. This is lesson 6.3. I'm going to give you the highlights of 6.3, and there'll be one thing new in 6.3 that's different from 6.1 or 6.2, but a lot of it builds on 6.1 and 6.2, so I don't want to repeat those parts that you're probably already pretty good at. So I want to show you the new part in 6.3, but not go over quite as much the old parts. Okay, so an old part used to be, the question would be, find the sine of x, and sine of x equals root 3 over 2. So what values of x will the sine equal square root of 3 over 2? It'll give you an interval from 0 to pi, and you pull out your unit circle, or you'd think through it and think, wait, sine, the y-coordinate, what does it equal the square root of 3 over 2? It turns out a couple places, at pi thirds and at 2 pi thirds, the y-coordinate is square root of 3 over 2. Okay. New today will be, what about the sine of 2x, or the sine of 7x, or the sine of 15x? When it's a multiple angle in there, how will that make it any different? And you might remember in previous chapter we had double angle identities, but even now it won't be just double angle identities, it'd be sine of 5x, sine of 3x, sine of 7x, all of these multiples of the angle. And so the question is, what does that do to our problem? And one nice way to understand it is look at it graphically. So let's look at the graph of sine of x. And then remember, what does the graph of the sine of 2x look like? Okay, so let's graph this just to see what we're doing here. So I've got y equals, let me just scoot over so we can remember our question here. So we've got y equals the sine of x. So I'm going to go y equals, clear that out, and we'll put in sine of x. Then, one thing we could do, we wanted to see where the sine of x, we wanted to know where that equaled the square root of 3 over 2. So I can pull up this and say, well, why don't I just graph the square root of 3 over 2? So second square root of 3 divided by 2. And then the question becomes, where does sine x equal square root of 3 over 2? The question becomes, where do these graphs intersect? And just to make it a little bit easier to see, let's switch our mode to degrees, because it's just a little easier in the degrees to see this sometimes. And then let's choose a window. Let's go from 0 to 360, because there's 360 degrees. We can count by 90, something like that would be okay. And then our y's, well, we know sine goes from 1 to negative 1, negative 1 to 1. So let's go maybe negative 1.5. Get the 5, there we go, 1.5 to 1.5. That way we'll get everything fit on there. Okay, let's graph. Here's our first graph. There's the sine graph, no big deal. And then here comes the square root of 3 over 2. Let me just save that graph. Bring that over here. And so what are we doing graphically when we're solving this? We're finding the two places on the graph where the sine of x, which is this curve here, equals our line square root of 3 over 2. So we're looking for those two places right there. And let's just pull that calculator back up again and let's look and see if we could trace on it. I could plug in 60 degrees. And sure enough, that's one of the places where they equal. I could put in 120 degrees. And that's the other place that they're equal. Okay, so what does the sine of 2x do to this? And again, if you think back to chapter 4, we spent a lot of time graphing. You guys are really good at graphing. The 2 affects the period. It makes your graph occur twice as frequently. So now when we graph this, we hit graph, and we get the sine wave. Look at that, it occurs twice as frequently. And we still get that square root of 3 over 2. And so the question becomes, let me save that graph now. The question becomes, where does it hit now? Where are those points? And hopefully you'll look and say, well, it's not going to be 60 and 120 anymore. This graph is occurring twice as frequently, so you might have an inkling there. So instead of here, this was 60 and 120 degrees. Well, if the graph is occurring twice as frequently, maybe you're leaning towards 30 degrees. Oops, 30 degrees. And 60 degrees. We'll check that in a minute. But then the question becomes, well, wait a minute. What are these two new points over here? What would they be? And how do they differ from the first two? And so let's explore that a little bit with our calculator. Then we'll come back and see if this makes sense to us. Okay, so let's explore it. Where do these two graphs intersect? Let's trace. They used to intersect at 60. This graph's going twice as fast, so let's try 30. And sure enough, that's one of the points. It used to be 120. It's going twice as fast. Oops, so not 120. Let's try 60 this time. And we get that one. So how do we get the other two? Well, we know a trig function normally repeats every 360 degrees. Sine of 2x is going twice as fast. So let me let's keep track of our answers and we'll come back to that. So we have our first 2 points, which are 30. Oops, sorry, and that's a 60. So 30 degrees and 60 degrees, and that's exactly half of those 2 answers. So then what about the other 2 answers? What are those answers going to be? And if you look at it, it's all nice and symmetric. How far is it from here to here? Or how far is it from here to here? How much farther is that? And if you look, you think, well, that's one period of our graph. And our period here is not 360 because of the 2x. Our period is 360 over 2. It's 180 degrees. So it seems like once we have one set of answers, we'll add on 180 degrees. We'll get 210 and a 240. Let's just see if that works, and then we'll practice this a whole lot more. Don't worry about it. So let's trace. I'm suspecting if I add on, I had a 30. If I add on 180, I get 210. I'm suspecting that's an answer. Oh, look at that. That's perfect. Or 60 plus 180. Okay, what's 60 plus 180? Oh, that's 240. And look at that. That's our other answer. So we can find these other spots. So first of all, we notice there's 4 answers now instead of 2 answers because the graph is occurring twice as frequently. Once I get one set of answers, I just add on the period, the 180, to get the next set. Okay, let's see if we make sense out of this with a couple of problems. Here's the method, and we'll see if we make sense out of this. So if you were going to solve the sine of 5x or the sine of 3x, just solve instead the sine of x problem. Just do that. Okay, and I think we're going to stick to the degrees. And so what we're going to do is, to each solution in part 1, add on 360, because it keeps repeating. Excuse me. And if it's a sine of 4x, add this on 3 more times. You've got your initial solutions plus 3 more sets, so a total of 4 sets of solutions. And then, if it's a 4 in there, divide all of your solutions by 4. Okay, let's try this, see if we make sense out of it, and we'll come back and look at it again. So, cosine of 2x equals -1/2. What you're going to do is just go cosine of x equals -1/2. We're going to solve this problem. So think through, cosine is the x-coordinate. We're going to go in degrees. Where's your x-coordinate? -1/2. If you look through that, wouldn't that have been at 120 degrees? Did you get the other one? 240 degrees? Okay, we've got a 2x in here, so our graph is occurring twice as frequently. So to each of these answers, I'm going to add on a 360. And when I do that, I get a 480 and a 600. So I now have 4 answers. I have my first 2, 120 degrees, 240 degrees, then I have a 480 degrees, and a 600 degrees. Got those 4, and I realized, wait, this is occurring twice as frequently, so every single one of these gets divided by 2. And what are my final answers? 60 degrees, 120 degrees, 240 degrees, and 300 degrees. All right, let's check that and see if that makes any sense. Let's graph the cosine of 2x. Let's graph -1/2 and see if those actually work out. So you can't really prove things with a calculator, but it certainly helps us verify a bit here. So here's the cosine of 2x. We'll change that to cosine. Here's -1/2. And I suspect they're going to hit in these 4 spots. There goes our cosine graph, occurring twice as frequently. And there's our -1/2. We'll trace on it. Do they really hit at 60 degrees? Yes, they do. 120 degrees. This is going to be too good to be true. Oh, look at that. 240 degrees. Yes, and the last one was 300. 4 in a row. That is perfect. All right, Let's try one more. I think you're going to have this method down. All right, sine of 3x equals 1. Don't solve sine of 3x. Come over here on the side. Solve sine of x. Where's the y coordinate 1 when x is 90 degrees? Except there's a 3 in here, so we're expecting 3 times as many answers. Add on 360s. 90 plus 360 is 450 degrees. Add on another 360. 450 plus 360 is 810 degrees. But don't take those 3 answers because we got that 3 in there. Divide these by 3. And 810 divided by 3, and I end up with a 30 degrees, or a 150 degrees, or a 270 degrees. And those will be the 3 spots where the sine of 3x equals 1. So it's going 3 times as frequently. I'm expecting those 3 answers. This is a nice, quick, easy way to get those 3 answers. All right, that's our first part. That's the main idea. There's a couple tricky parts that come later. That'll be in the second video.